Welcome to Image Processing with ArcGIS Pro. 12 YouTube videos summarize image processing lab exercises available in a step-by-step lab manual that accompanies this textbook. Download the lab manuals at the site shown and obtain more textbook information at the second site shown publisher's website. Download the lab manual and data used in the lab exercises if you want to use the step-by-step instructions and process the imagery and DEMs while viewing the YouTube videos. The examples used in the videos and lab manual are discussed and shown in the textbook, improving GIS student understanding of essential remote sensing principles and technology while learning how to process and enhance images and DEMs using ArcGIS Pro. The lab manual, a page is shown in the upper right, and 12 YouTube videos are designed for GIS instructors, students, and users who want to do their own processing, enhancement, and information extraction of satellite and airborne images and DEMs using ArcGIS Pro. You can see the 12 exercises, the tutorials listed here. They cover a broad range of image processing tasks, algorithms, and help you find where these tasks are located on the various menus in ArcGIS Pro. The lab exercises require ArcGIS Spatial Analyst extension. Contact Ellis at ellis-geospatial.com for any questions or comments, and visit the publisher's website for more information and resources on the textbook. Our final Lab 12 provides an overview of the remarkable National Land Cover Database, NLCD, provided by a partnership of federal agencies led by the USGS. Both examples in this lab are discussed and shown in the textbook. On the lower left here you can see the legend for the land cover map, and on the right you see the legend for the impervious map. The NLCD covers the whole U.S. It's been in existence for over 2 decades now. And so this is the 2006 database, and there's the agencies involved. We'll be looking at 2 types of map, the impervious, and this is the same area, the land cover. And we'll be working with the most recent version, the 2016 NLCD, up here in western New York, where I live now, and out in California. 2 sites that we'll be looking at. On the right you can see our Lab 12 data folder for land cover. The TIFFs, we've got a 6-band Landsat, the NLCD map, and then Space Shuttle DEM for this area we're going to look at. The data comes in a continental scale map projection. So I just scroll down, spatial reference. You can see it's a projected coordinate system that's appropriate for the whole North America. And what we're going to do is start with our little subscene, which I extracted from the huge national database, and set our view into UTM 17 North with the datum WGS84. I'll set that up now. We want our map view in the UTM system. So we go to coordinate systems, and we're going to go to projected, UTM, WGS80 Northern Hemisphere, and as you scroll down, get to 17 North. And you can see what it did to the streaming map. Significant change, because we're interested in this area, and now our Landsat and images we bring in, I'll begin to load the TIFF files from the land cover folder into the contents. I'll start with the Landsat, then bring in Space Shuttle DEM, and then bring in the hillshade. And finally, this is my little subscene of the NLCD that I extracted. So you can see the colors, and we'll look at this in a little bit. So what I'm going to do now is enhance these 3 so that we can then interpret why are these colors the way they are in our land cover map. So first I'll work on the DEM. Go to symbology, min-max. I want the rainbow thermometer on this. I've got the rainbow thermometer. This is my hillshade. I'll just brighten it up a bit, and it would be nice to fade this on top of the color DEM. 60%. Go to the Landsat. Have to highlight the Landsat and make it a natural color. So you can see in our scene we've got a large reservoir, what looks like forested terrain with vegetation and agricultural area here, and down in this area a major Air Force base, runways, and suburbia starting to come in. Give you some idea about where you're located. This is the Niagara River coming out of Lake Erie. This is Niagara Falls right here. And the water flows down the Niagara Gorge and it goes into Lake Ontario. And I live over in this area now. So we can interpret the area with the Landsat. And we've got this Space Shuttle DEM, which shows, interesting blues are holes. So this is the Niagara Escarpment, which Niagara Falls flows over as it goes north out of the Lake Erie to Lake Ontario. This is that large man-made reservoir that's used for hydroelectric power. And then finally the NLCD. And if I open the legend on this, you can see it's a thematic raster map with 256 categories that you can fill up. And USGS only fills certain ones with the colors. And so if I bring over the legend, where actually these are the only ones that have colors out of the 256 bins, let's call it. And so you have to correlate the number that's developed low intensity. You have to correlate the number in their legend with what you see on the legend that's printed up. The USGS legend has 20 classes. Let's look at the attribute table. And in Western New York, you can see that there's only 15 classes that are filled. And then count the number of pixels for each of these classes. And here's the numbers that we need. Like 21 is developed low intensity, open space 22. So I said, can I simplify this so that we don't have such a long list of symbols that aren't used, but get it down so that only the 15 show up. So this is one way that I did that for my subscene. Right click on symbology. Instead of color map, I found if I go to unique values, I end up with my 15 classes. But unfortunately, I lose the colors. And so what you could do is go through and individually right click and put the same colors in that you see in the USGS color code. And I did that for you. So this could be an exercise that you want to do, but here's the layer file. Now I just have to connect it back to the data. And now you can see I've got my colors and my numbers showing up, and I'm ready to go. So I said, well, it'd be great if in the attribute table if I could add the name of the class so that 21 is actually this low density open space. But I found I couldn't do that. That for some reason I get the same error I got trying to do it in another lab exercise. I get an error message. I'm unable to add a field to this raster thematic map, the attribute table. So I just have to have this legend up somewhere so I can see it when I'm going around and inquiring about why is this color here? So I just want to show the value of having these other data sets. So I've got this gray. The gray is barren land, rock, sand, clay. And if I say, well, wonder what it looks like in the DEM. And you can see it's a hole in the DEM. And if I put the land use on top and I say, why don't I fade this a bit? See how nicely it fits? So what kind of landform is that? This is the Landsat. We're assuming we don't have higher resolution image to look at. So you can help, by using the DEM, you can help interpret what that feature is in the land cover map. The same goes if I come up here to this cliff, and you'll see that, make this more opaque, there's a class that dominates along here, the green and the light blue, but you can see it's this green deciduous forest, wetlands, and what sort of topography is under that. You see it's the Niagara Escarpment, and you can back off. And so just showing, this is just a demo showing that I'm bringing other data sets to help you interpret why has the USGS picked that land class for that area. The dark brown, cultivated crops, and there they are, all the cultivated crops. So with that, we'll conclude just looking at the National Land Cover Map, which is truly a remarkable contribution. We'll move on to San Francisco and look at the impervious layer that the USGS puts out. Now we've moved to the West Coast. We're looking at San Francisco. In our folder, in the data folder, we have the Landsat 6 bands. I've loaded in enhanced color, the impervious layer, and the land cover from NLCD. So you can see in the Landsat the areas that are parks, the water going around, and actually the shadows from all the big towers downtown. So we'll load up the land cover first. You can see it's got a lot of red. If we go back to our JPEG of the legend, we can see that there's a tremendous amount of deep red here in San Francisco, down in this area, over on the Oakland side. So it's a really heavily populated area in the US. All these reds, high intensity, downtown, both places. We'll interrogate the land cover map. I've highlighted it differently than we did before. Now we use the information tool. And so zoomed in, and you can see it's a little blurry, and that's where before we start we want to resample back to the nearest neighbor. So we're looking at the actual pixels themselves. And then with our cursor, we get this pop-up with the information tool. And here we can see the color map, the pixel value, it's number 82. And 82 in our table is cultivated crops right here in the middle of San Francisco. I'll go over to the deep red. 24, developed high intensity. And so as I click around, I not only get the name here, develop medium intensity, but I get the colors that I can use to reproduce this in another system. So I've got red, green, blue, what makes this color, and how many pixels there are of this class in the area. We'll go over to this blue, and that's open water. More open water. Come down here, evergreen forest. So you can use the image information tool, push the C button to roam around to see what these different classes are. Mixed forest, shrub, scrub. And if we right click on our land cover, open the attribute table, see this has the names in it along with the colors that are used to make. So you can see the 0 open water loops on both sides. So I'll clear the selection, zoom out a bit, and turn on the impervious layer. Now I'll highlight the impervious layer, and we can zoom in. We want to make sure that our resampling type is nearest neighbor, so we can specifically ask what is your percent of imperviousness. It goes from 1 to 100, 0 to 100 actually, and you can see, I'll close this. Once again, we have a very extensive symbology legend going up to 100, and that's the highest level, the purples. And then there's zeros in the middle of the area. So we can roam around and have to hit the C key to roam around. If you want to know what that land use is, I'll pop my over here, collapse this very long legend. That's the thematic raster map legend. And if we want to know what that feature is, we can turn on the Landsat or other higher resolution imagery and see it's some sort of parkland. Now I'll zoom out again and then open up the attribute table. There. And these are the count for the different levels of impervious. You can see there's a tremendous amount in 0. And so if we zoom out, you can see what feature 0 is, but it's also not just offshore, it's inshore. So what are these polygons? So I can interrogate. I've got my impervious layer, and they're 0, and it's highlighted, so they're 0. But what's the land cover? And so I can see it's trees and grass and shrubs and scrubs, and so it's got a high permeability. And in these areas must be the roads and things like that, the trails going through the system. And you can see the park in that close-up, Golden Gate Park. But it seems that if I highlight the impervious, on the right side you can see I'm getting the levels of impermeability. It's going from 96 to 97. Might be too small to see on the videos, but that's this area. If I highlight the land cover underneath, then I get those values, 23, 24, the high density population. Up here we're more into the scrub and shrub and trees. But when I click on it, is whatever layers on the top of my content seems to work the pop-up button. So if I want to see what this is in the land cover with the pop-up, it appears I have to open water, evergreen forest. I have to move my land cover to the top to have the pop-up work. The image information gives the correct values on the right side, but in the pop-up it seems the feature that you're trying to query has to be at the top of the list. I'll turn those two off, highlight the Landsat, and you can see it's really cool because once again we see all 6 bands, how they're responding, and then this green is band 4 on the right side. So that's band 4, the near IR. We'll come down into the urban areas and you see it's not, band 4 isn't as pronounced because it's responding to the vegetation. So that image information tool is really handy to interrogate, zoom to layer. To clear the selected row, you go up here to this clear button. So that concludes our interrogation of the NLCD data, the impervious layer, the land cover layer, and then you can bring in your Landsat and of course topography also to help understand what kind of feature are we looking at in this USGS map. It's a remarkable contribution to anyone working in the USA, and that includes Alaska and Hawaii, to help provide a really accurate land cover impervious layer base for your own studies using image processing techniques.